All right, we're going to go ahead and start in chapter 3 now. And chapter 3 is all about graphing. We're going to start off by talking about points and plotting points. We're going to then talk about a little bit of graphing lines. We're going to talk about intercepts and slopes. We're going to end up graphing lines, and we're going to end up writing equations of lines. Now, before we get too deep into lines, let's talk about how to read other graphs like bar graphs, line graphs, and even pie charts. So if you look at example number 1 in 3.1, it gives us a bar graph. We have to first figure out what this bar graph is representing. It looks like on the horizontal axis, those are years, right? It looks like the year 1999 all the way to 2001. It looks like on the vertical axis, those are numbers representing the number of police officers. So it looks like these are the number of police officers from 1993 to 2001. Okay, now that we know that information, we should hopefully be able to answer the questions using this bar graph. So, example number 1A says how many police officers were there in 1999? So we have to find 1999 on our graph. We need to be able to follow the bar up to the top and figure out how many police officers there were in that year. If you kind of follow it over to the amount, it's a little bit above 50, not quite to halfway, a little bit lower than that, because my line's not very straight. But if you followed it over, it's a little bit above 50, but not quite 55. So we're not going to be able to get exact, but we should be able to estimate that there were about 51 or 52 police officers that year. All right, what about B? In which year did the number of police officers exceed 50? Well, exceed means more than, right? And so we need to kind of use this a little bit backwards this time and kind of start with the value of 50. And this is the value of 50. And we want to figure out what bars or what years are more than that. It looks like 1993, 1994, 1999, 2000, and 2001. So in all of those years, the number of police officers exceeded 50. Make sure you know how to read and interpret a bar graph. Let's do an example of a line graph. It looks like this line graph on the horizontal axis is talking about the months in 1993, so January to December of the year 1993. It looks like along the vertical axis, this is the discharge of, it looks like, the Red River discharge rate. So I'm assuming the amount of water that's going out of the river, right? In cubic feet per second. Okay, so example number 2A says, what was the rate in April of 1993? So let's find April. Let's follow it up on the line graph, and let's figure out approximately what the rate was that month. So if I follow it over, I end up getting approximately 18,000 cubic feet per second. You notice that I didn't just write 18,000, I actually labeled it so we knew what the number meant. 18,000 cubic feet of water per second was discharged in April. All right, B says, during which month was the rate the highest? Well, it's kind of easy to see on a line graph because it has hills and valleys. We want to find the highest peak. So it looks like the highest peak happens in August. All right, the last one, example number 2, says between August and December, did the rate increase or decrease? Well, here's August, here's December. If I were to follow it, would I be going up or down? And we always read it from left to right. So it looks like I'd be going down, which means my rate is decreasing in that time span. All right, the last one we're going to talk about is a circular graph called a pie chart. A lot of times we use pie graphs when we have and talk about percents. So it looks like in example number 3, it says in a national survey of 292 million students, students showed these preferences for instructional material. It looks like some preferred computers, some preferred radio, film, lecture, TV, and written, and they give us the percent of each. Let's go ahead and answer the questions using this pie graph. Number 1 says, about how many students would you expect to prefer computers? So let's go over to the pie graph, find computers, and it looks like about 36% of students. But now be careful. The question didn't ask us what percent of students, it asked us how many students. So we've got to figure out what amount that is. But I do know that it's 36% of all the students in the survey. So 36% of 292 million students. Now we've got to do a little bit of math and figure out what that number is. Now maybe you remember from a past class or a previous section of how to calculate percent. We know that in math, of represents multiplication, so I can take 292 million and multiply it by 36%. Or I can take 292 and multiply it by 0.36, which is 36% as a decimal. So 292 times 0.36 gives me 105.12. But not just 105.12 students, 105.12 million students, making sure that I label it correctly because it means something very different, right? All right, what about 2? 2 says, about how many students would you expect to prefer radio? Well, that's similar to number 1, so maybe you can try this one on your own. Maybe pause the video and figure out how many students you expect to prefer radio. All right, using my pie graph, I noticed that about 5% of students preferred radio, but I need to make sure that I calculate how many students that is. So I need to figure out what 5% of 292 million is. That means I'm going to take 292 and I'm going to multiply it by 0.05. That's 5% as a decimal. When I do that, I end up getting 14.6 million students. Did you get the same thing? And you labeled it properly, right? Okay, perfect. Make sure that you know how to interpret pie graphs, line graphs, and bar graphs.